All right, we have like 30 minutes left. So I'd like to do the lecture tutorial, but first we're going to look at the data lab. And if you're watching this online and you want access to all this stuff, the files and everything, the links in the description, so that no matter where you are in the world, you can learn statistics. So here are the, that's our slides, don't need it. And data lab. The big picture, the task, materials and procedures, the scaffold, analysis questions. So you met the penguins, you drew a random sample, right? In week 2, you drew their pictures. So the histogram, whatever we drew. This week, you compress those pictures into honest numbers, center and spread body mass separately for each, mean, median, SD, 5-number summary, IQR, plus the 1.5 IQR rule. Then comes the fun part. You'll sabotage your own data set. One fat-fingered typo, penguin entered at an impossible 9999 grams, gets injected on purpose. You'll watch live summaries lurch, the mean, the standard deviation, which shrug, the median, the IQR. So these are not resistant, the mean and standard deviation. These are resistant, the mean and the IQR. That's this week's biggest data idea. Resistance demonstrated on real research data by you. The data is the same as weeks 1 and 2, 344 penguins. The task, the guiding question, how different are the 3 penguin species in body mass, in center, and in spread? And what happens to each summary when one impossible value sneaks into the data? The data set, both links are free, no login, about the data, and the data itself. So I'm going to get this data here. I'm going to just copy it, Command C, and if I go here, it's just going to show me the data, right? So to fix that, I need to see if it doesn't let me highlight it. So let me edit this. Anybody feel like they're trapped in the Matrix? Ever? You ever have that feeling, anybody? Like, dude, I'm so trapped in my own conditioning. Anybody ever have that feeling? No? Say aye if you do. Sometimes I have that feeling. Save this link as. I'm going to save it as my data, and I'm going to just put CSV on it because I know it's CSV. I'm going to save that right here to my desktop and use CSV. And then I'm going to come over here to Google Drive, and I'm going to drag it in. I'm just showing you how to do this. Desktop. Where's my desktop? Penguin, CSV. I'm going to drag this in here. And for this to work inside your Google Drive, you have to go to Settings. And then in Settings, you have to make sure Convert Uploads to Google Docs format. So now if I drag a CSV in, it's going to convert it. But I gotta name it something new because I already have a Penguins file. I'm going to call it Penguins 777. And now I'm going to drop it. And there's my untitled spreadsheet. It didn't name it for me after the file name. I'm going to, hey, no, that's not it. Where is it? Where's my penguins? There it is. All right. Now I have my penguin 77. Here are all my penguins. I'm only going to be dealing with body mass. So I'm going to just click these rows. Whoop, 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 and right click and delete those columns. And I guess I'll keep their gender because I'm kind of curious about something. I'm going to delete this. I don't need that column. And we got the island, we got the body mass, and we have the gender. I'm going to bold these headings. Just select that, hit bold. I'm going to go to View. I'm going to go to Show. Sorry, I'm going to go to View, Freeze, and one row. So I got that top row frozen. So as I scroll, that stays in place. So I'm happy with all that. And now I want to calculate things like the mean, the median, the mode. And to calculate that, I'm going to sort this data. So I'm going to select this data here, just select all that. Go to Data, go to Sort Range, Advanced Sort Range. My data has a header row, and sort by body mass, A to Z. And that sorted it low to high. I kind of want to delete this one data point that's NA, just so it's not there, me having to deal with it. I'm going to delete both those, okay? Just because. And now my mean, I do equals mean. I know how to calculate, I have to do average. I know how to calculate this manually, right? But, you know, sum it all up, divide by the total. There's 342 because I deleted 2 records that were NA. And there's my mean. Now my median, right, is going to be that C2 through C343. You're following me, say I. You're not following me, say no AI. No I. Good. I'll assume you're following me. So I'm going to make this a little bigger. So there's my mean, my median. What's my mode? Equals mode, modula mode. And it's going to be mode for all this, C2 through C433. I don't want to autofill. And my mode is 3800. Mean, median, mode. What's my variance? Right? What comes first? Variance and then standard deviation. Variance is the s squared for a sample. Standard deviation is the square root of s squared, or square root of variance. So I'm going to do my variance. And I could just do, you know, if I did this manually, how would I do it? You want to see it manually just so you start to get it? Say I if you do. Nobody wants to see it manually? Only Kat? Yeah. Kat, you're in the 1%. I love it. All right. So for my variance, I need to calculate this formula here, which is going to be each data point minus the mean, square, add them all up, divide by n minus 1. Okay, that's my variance. It's right here. Each data point minus the mean, square it, add all that up, sigma, divide by n minus 1. That will give me my variance. So to calculate it manually, it's going to be this is going to be xi minus x bar. Okay? It's going to be each data point, which is going to be this data point, minus the mean right there. And I'm going to F4 that, put dollar signs on each side, function F4. Dollar sign on the column reference, dollar sign on the row reference. The column is H, the row is 3. I'm holding that constant. I'm subtracting the cell immediately to the left. I'm going to press enter. I'll go with autofill. Right? So there are all my numbers. Now I'm going to square that. So that's going to be this. Squared. It's going to be equal to that times that. Okay? Fill it in. And now I'm going to sum it up. Going to be a big number. And I'm going to take that number, which is E344, and divide. It's going to be equal to E344 divided by n minus 1. My n is 342, so 342 minus 1 is 341. N is how many, right? And if I wanted to, I could do here, count the number of numerical values in a data set, and it's going to be all of these. And so that gave me 641,250. And I'm just going to see if instead of count, I had 341 here. 643,131. I think those are different numbers. So what did my count give me? Equals count. Ooh, I'll just grab it from here. Equal sign to make it work. Gave me 342. I guess that's right. Did I say 341? 344. Are those the same? Those are the same. All right. Yeah, but I subtracted the 2 NAs. Oh, but yeah, because they won't have subtracted the 2 NAs, so I should do 3, 4, 4, right? I'm going with 3, 4, 2. We're doing it my way. And now we're going to do standard deviation, and that's going to be equal to the square root of my variance. And I could check that by just doing standard deviation here, the formula, and I could say all these numbers here. And they should be the same. Close enough. Right? So here is the spreadsheet calculation of standard deviation. And here is my standard deviation. I'm going to go with spreadsheet calculation. And then it says it wants me to add in some large numbers. And a fat-fingered typo of 9999. And let's watch what numbers move. Here, before we do that, let's copy these numbers over and paste them as values. Edit, paste special, values. So as I add in the big number, these will stay the same, and these will change, and we'll see which ones update. Right? So here the mean got pulled, what? 21 by one big number. Let's say we make it even bigger. The mean got pulled 200 by one big number. The median didn't change. The mode didn't change. Right? And the standard deviation got pulled a lot. The standard deviation got pulled a lot. Right? Look at that. Standard deviation, not quite so much, but with the bigger number, it did a lot. So standard deviation and mean are not resistant to outliers. And then it wants us to do the 1.5 times IQR, which means we need our IQR, right? So what's our Q1? What's our Q2? What's our Q3? How do we find our Q1, Q2, Q3? How do we find that? I'm going to move this number back to what it was. How do we find that? Here's Q1. Here's how you do it with a spreadsheet. Like with a lot of numbers, we could, right? If it's like just these numbers up here, we could find Q2, the median. Okay, it's the middle. And then we could take the stuff on the left and find that middle, and that's your Q1. We could take the stuff on the right and find that middle, and that's your Q3. But here, let's see if there's a Q1. So to do that, I'm going to go to help. I need somebody, help. Not just anybody, help. And I'm just going to do a command F, Q1. Doesn't find anything. And quartile. And statistics, quartile. Returns a value nearest to specified quartile of a data set. And quartile, C quartile, returns the nearest given quartile of data set. And data, quartile number. I don't know. We could play with that, quartile, see what it does. So we enter the data, and then we enter the quartile number. We can learn more here. Quartile function, A2 through 100, 3. A2 through 100, B2. Data quartile is the array data quartile number. Which quartile value to return? Returns data closest to the first quartile, second quartile, third quartile. I like it. Let's use it. So we're going to do Q1 is going to be equal to quartile, and we need to enter our data, which is all this. And then we need to enter the quartile number, which is the first quartile. Is that the one I want? The first quartile, yeah, first quartile, 25% mark. That's our Q1. And then here's our Q2. Quartile. Well, I could just do this. I'm going to hold these constant by putting the dollar signs in front of them. Now I could copy this down. That's not what I wanted to do. Come on, man. Ooh. Option backtick. Why is it not working? Command backtick? That's not it. Control backtick? There we go. So as I copy this down, right, it's the same thing. And I could just change these to third quartile. You see what I'm doing? Say aye if you see what I'm doing. Aye. Okay, and then go back out of formula view. And there's my first, second, and third quartile. And then my IQR is what? It's going to be equal to this minus that. That's the stuff in the middle. And then my 1.5 times IQR is going to be equal to 1.5 times IQR, 1800. And then my low fence and my high fence is going to be, how do we calculate that?
The lower fence is interquartile range minus the Q1, or the Q1 minus the interquartile range 1.5 for the lower fence, and for the upper fence it's Q3 plus the 1.5.
Okay, so it's Q1 minus Q3 plus, right?
Yeah.
So here is lower fence is Q1 minus and Q3 plus for the upper fence. So thank you. My low fence is Q1 minus that. And my high fence is Q3 plus that. So any data that's lower than 1750 or higher than 6550 is going to be an outlier, right? And so we could check that. So I'm just going to put in a couple of columns here. And we could say less than low fence, greater than high fence. And then we could also put z-score here. And so for high fence is, low fence is 1750. And so we could do equals this less than that. And we'll make that constant so we could copy it down. Okay. Boop. And nothing is less than 1750. And we could do equals this greater than that, and we'll make that constant and copy it down. And then we could go down there and we could see if we have any outliers. But if we had an outlier, because our fence is 1750, like if this was 1700, right, it'd say, oop, there's an outlier. Or if this was 6600, oh, there's an outlier, right? Isn't that cool? And then we could calculate the z-score for each of these. So our z-score is equal to this minus the mean. And we want the mean to stay constant. Come on. What's your problem? There we go. And we divide by what with our z-score? It's a point minus the mean divided by what? Come on, people. How do you calculate the z-score? 1%. Who's living in?
Minus mean divided by standard deviation.
Yes. So it's a point minus the mean divided by the standard deviation, because you want to see how many standard deviations is a certain point away from the mean. Right? Yeah. And if it's like 3, you're like, boy, that person gets on base. We're hiring him. Okay? And so here the z-score is going to be divided by standard deviation, which is that. And I'm going to put dollar signs on each side of it, hold it constant. Boom. So there are my z-scores. All right? And so these are 1.87 standard deviations away from the mean, which is like almost 2 or almost 1600. 2 times that would be 1600 less than this. 1600 less than 4200 is about 2700. That makes sense, right? And then way down here, this stuff is like right on the mean, these two, right? Because the mean is 4200, I think. What's the mean? 4201. Like this is what we're looking at, these z-scores. You know? And then out here, whoa, this one's a long ways away from this. This is a fat penguin. This penguin's fat. So if we wanted to, let's say we're farmers, okay? We're farmers. And we want to start, and we raise penguin because it's the new barbecue phenomena. Like a thing blew up on TikTok, penguin meat. Oh my gosh, penguin meat is the best. It's so good, bro. When you grill penguin meat, it is so good. And we want to raise big, fat, heavy penguins because that means we're getting more meat for every penguin. So we want to start breeding our penguins, right? So that they get bigger and bigger and bigger. And so we're going to select the biggest penguins and put them in a room and turn on some Barry Manilow and turn down the lights. And we're going to have those big penguins mate because then they're going to have bigger penguins. Like, this might seem ludicrous.
That's how everything
Dude,
happened.
but you could go to, like, what's the big meat place that's out there when you're driving to Kalinga?
Oh, there's a butcher, like a whole
No, it's the farm. It's like
okay,
it's like a
farmhouse,
kind of steak that they sell at the grocery store. It's like,
Wagyu beef and stuff.
I don't know what it is. But you could go and you could be like, hey, you want bigger cattle? I could show you how to do it.
That's how they do Wagyu beef in China. They breed and they breed the. That's how you do any animal. You breed them statistically to get the certain eye colors.
Right.
Yeah.
So look, if we wanted to, this is like going to be, these are our number one guys, right? Like these two right here. They're going to be making all the babies. And then for our females, right? Like this one, she's like the biggest female. And like these, we're just going to pick out the biggest females, all these right here. And those are the ones we're going to breed. You know, like, all right, go get the Barry Manilow. We got a plan to put into action. Is that funny at all to you?
Yeah.
A little bit? Sorry. Try to keep statistics interesting. Isn't that interesting? So did we do everything here we need to do with this assignment? What are we supposed to do? Data, materials, and procedure. And it wants us to import it, split the masses. They want us to only look at certain kinds. Count each column. So count how many are in each one. And then, I don't know, here, quartile, min, max, quartile. So we average, standard deviation, quartile. You know, we did all average, median, standard deviation. We did all that. So that's kind of what you do. How many people are like, I get it. It kind of makes a little sense. I like it, say I. How many people are a little surprised to feel a little excited about statistics, say I. How many people are still like, say no, I.
Nobody wants to admit to being dumb.
No, you can say you're not into it. I'll admit I'm dumb. I'm 100% dumb on so many things. There are so many things I'm dumb about. I can't even tell you. One of the world's greatest quantum physicists said, if you think you understand quantum physics, you don't understand quantum physics. Think about that. He's one of the smartest people about quantum physics. And he said, if you think you understand it, you don't understand it. Because to truly understand it is to understand you don't understand. It's just like not understandable. And, you know, there's so many things in the world that this illusion of being an expert is a foible. It's a fault. Like you have to know you don't know. That's one of the most important things you can know is that you do not know. So, all right. What else is there to do? The lecture tutorial. Let's do it.